welcome everybody once again to my latest office hours. This one is, I'm calling it a pop-up session because I announced it less than 24 hours in advance. It's going to be a relatively short one too. I'm going to try and keep it to around 30 minutes or so, partly so that I can actually write the blog post about the upcoming weather events that I need to in the context of this week's very busy schedule. I'm going to try and write that blog post for publication this afternoon, so keep an eye out for that on the Weather West blog. Most of you who follow these YouTube sessions are probably already aware that I author the Weather West blog at weatherwest.com. But if not, this will be a great opportunity to check it out. Although you might want to wait a couple hours until later this afternoon when I have the new post out about the upcoming Western U.S. heat wave, as usual, with an emphasis on what it means for California. This is going to be a bit of a weird event, and this is why I wanted to talk about it today. I will probably have another brief session next week, another 30-minute session early next week to talk about this, because honestly, it's a pretty unusual setup, and there's still some substantial uncertainties regarding how it might unfold, given that it's an event that may last in some parts of the West for 2+ weeks. That's a long time, and the details more than a few days in advance are a little bit fuzzy. So I want to talk about primarily this event today. So as I mentioned, it'll be a bit of a short session. I will still, as always, take some questions at the end of the session, so please add them in the chat, but I'm going to try and keep them pretty tightly constrained to this upcoming event. Given the shortness of today's session and the fact that the focus is on this upcoming weather event. So I'm going to be showing a lot of maps today. I know folks tend to like that, so this is your day if you like that kind of stuff. But I did want to give a quick little overview of what I think is going to happen, and then I'll dive into the maps in just a minute. It does look like a significant early season heat wave is headed for really much of Western North America, not just California. In fact, maybe not even primarily California, but especially some of the adjacent states farther to the north and east, so the interior West in particular, and not so much the Southwest. This won't be a desert Southwest focused event as many early season events are, but instead this will be kind of unusual. This will be aligned farther to the north, maximized perhaps from far northern California into the Pacific Northwest and even into the interior of British Columbia, maybe, or other parts of Western Canada, maybe extending into Western Alberta as well. So this is going to be another, I'm not, just to be clear, I'm not comparing this in terms of magnitude to the June 2021 event, but there are going to be some similarities in terms of, well, the time of year. This is going to be an early to mid-June type event once again, but also it's going to be produced by a persistent and very unusually strong and located high-pressure system, so mid-tropospheric ridging at well above average to nearly record-breaking levels across the interior Pacific Northwest and southwestern Canada. If you recall, that heat event too in California was definitely a severe heat wave, but it was not nearly as extreme as it was in the Pacific Northwest. This may play out, at least in spatial patterns, somewhat similarly, even though again, right now there's no indication that this event is likely to be as extreme as that one in June 2021, but structurally there may be some similarities, both in terms of what's causing it, its formation, which will be kind of honestly weird once again, although maybe less weird seeing it the second time. And it's one of those things where maybe if we look back in history, there were similar events that formed for similar reasons that we kind of just missed or didn't think about as much at the time. And also how California might be kind of on the edge of this. There definitely are going to be some really hot days, especially in the interior of California and in northern and eastern California. So this looks like it's a heat event that's going to be maximized, at least from a California perspective, away from the coast, but not necessarily in the inland desert regions that usually experience early season severe heat waves to the same extent as it will be in the northern mountains of California, maybe the most anomalously warm places in the state during this event. So Reno, Tahoe, up by Shasta, these are going to be places that get really hot next week very early in the season, places that could approach record levels for this early in the calendar year. By that point, I don't think it's nearly as likely that places like the Bay Area or Los Angeles are going to see anything approaching record heat, although it might still end up being warmer than average. The immediate coast is probably going to continue to have a major marine influence. It's pretty hard to get extreme heat waves on Ocean Beach or in Santa Monica in early June, simply because of the cold, relatively cold water and the robust marine layer that exists. And I don't think this event is likely to be an exception in those places. So this will be another event where a fair chunk of California's population, the near coastal dwellers in the Bay Area and in Southern California, probably won't see extreme heat, but you might not have to go that far inland to see dramatically hotter temperatures. And if you go far enough inland, you might even see record-breaking heat. So another strong gradient. But this one will be sort of a southwest to northeast gradient rather than a west to east gradient. So in this case, it's the southeastern deserts probably won't see record heat with this event, but the northern mountains of California well could. Places, of course, that are less accustomed to extreme heat of that level, so it will probably have even greater impact. By the way, the Sierra Nevada snowpack, which did reach respectable levels this winter, coming in close to average around the April 1st historical peak, of the season, has dwindled pretty quickly. Despite being at 100% of average, give or take, around April 1st, has rapidly dropped to closer to 30 to 40% of average, with very sunny and slightly warmer but persistently warmer than average conditions in recent weeks. And it's very possible the upcoming heat wave will pretty much kill off what's left. So the remaining snowpack may be largely gone in 2 weeks, because that's the part of the state that is expected to experience the most anomalously hot and perhaps record-breakingly warm conditions with the event to come. So that won't pose problems in and of itself. There's not a tremendous amount of snow to melt, and a lot of it has already melted, so I wouldn't expect any snowmelt flooding, but the rivers will be running probably higher and quite cold once again, so that's sometimes a hazard for folks who go out to recreate during the heat waves and forget just how cold that water can be in those watersheds that drain the snowmelt portions of Northern California. And it also suggests that this is likely to kick fire season up a notch. There have been some fires in recent days, but again, nothing alarming, nothing particularly dangerous. There have been some mainly grass fires, which is what you'd expect at the early date. Some grasses in some areas are starting to dry out and cure. You can see on some of the webcams the green is turning to brown in some of the unshaded areas. Although the northern facing slopes and places that still have snow on the ground, of course, are not in those categories. But this upcoming heat wave will probably tend to dry out the lower elevations, accelerate the curing of the finer fuels, the grasses, the light brush at lower elevations, and also bring the mountain areas closer to something of a fire season, because it's going to really probably finish off that snowpack, the residual moisture from which will still be there in the soil column for a while. So I don't foresee extreme fire risk with this heat wave by any means. It's just too early in the season, and it has not been dry recently, so that's going to be less of an issue, although we probably will see an uptick in fire activity nonetheless. The likelihood of fast-moving, dangerous fires will be reasonably low. Never say never, but there's no real indication of extreme fire risk with this pattern. But it will set the stage for faster drying of vegetation in June, following a couple of wet winters, and could potentially accelerate wildfire conditions later in the season. So again, I don't really think this heat wave in itself is going to be the problem, but the more early season heat events we get, especially given the expectation of quite hot and unusually dry conditions late summer into fall across a lot of the West, what it might do is create the preconditions that make it easier to have a more severe fire season later than if we had a very mild start to the summer. So that's sort of the broader context, and now I want to dive into the maps, because honestly this pattern is weird and complicated enough that it's difficult to describe without some visual aids. So let me pull that up on my screen. You'll see it momentarily as usual. I just need to bring up the right window, which you will see right now. Getting a little bit better at this whole screen sharing thing, and also I'm going to zoom in a little bit on this so that you see less of the ad. Sorry, Levi, the ad won't show up. Although I guess you don't make any ad revenue just if people see the ad anyway. So neither here nor there. I'm going to zoom out a little bit since it's a little bit too much in. I can't quite navigate. All right. So I'm going to go with, this is the European model ensemble because it is the single, if you had to choose one best performing global weather model, these days it's probably the European, the ECMWF model, and always, I'm a bit of an ensemble evangelist, so I would always advocate for, especially when there are complex or complicated situations evolving, using the ensemble, meaning the consensus view, the average view, or the distribution across the many dozens of individual model members rather than the single deterministic run, which is quite stochastic and wiggles around every 6 hours every time you rerun it. There's a lot more consistency when you look at the ensemble averages. So the average across many dozens of iterations of the same model run with slightly perturbed initial conditions, and that's what we're looking at now for the Western U.S. domain. This is what things look like today, or as of earlier this morning at least. That's what this ensemble is showing. This is the most recent model run, and actually I'm going to go back to this because the 12 Zulu run isn't in yet. I'm going to go back to last night's run. Things haven't changed really since last night, and this will allow us to look out a full 2 weeks with the European ensemble. What we see, and I'm just going to make sure everybody is seeing things correctly. Looks like that's pretty good. Okay, so this is what we are experiencing today. There's some weak ridging along the west coast, but nothing too notable. It's slightly warmer than average, but really nothing to write home about at this point. As we go into the weekend, though, by the time we get to Sunday or early Monday, some of this stronger ridging builds in across California, and then by Tuesday or Wednesday, really starts to amplify across the whole West Coast. This is a major, arguably even verging on extreme ridge event by Wednesday, so June 6th, really extending from the northern tier of California, Nevada, and Utah all the way up through Washington and western Montana. And this continues to intensify, although it shifts even farther north and east as we get into the following weekend. So now we're around June 8th, heading towards June 10th. This is where we're out 10 days now in the future. The ensemble signal is weaker at this point and even more centered now across the Pacific Northwest and British Columbia, so moving away from California. Part of the weakening signal is just because we're far out in the future and the ensemble dispersion makes it a little bit harder to get a significant signal. But if you notice, it's still there across the west. Even though it's a little bit weaker as we go into mid-June, there still is a pretty robust signal for anomalous ridging across really all of the western U.S., with really California perhaps being at a bit of a minimum, but it's still there. And this is the normalized plot, by the way. Let me bring in the absolute values, and this may look a little bit different. And this is the same progression, but with the absolute values rather than the normalized values. And it gives you roughly the same picture. An event that peaks close to California is sort of the middle, late next week, and then shifts a little bit away from California, but persists across much of the rest of the West into mid-June. And what do the temperature anomalies look like during this time? Let's take a look at the 2 meter, so the near surface anomalies over the same period. As I mentioned, today we start out slightly warmer than average across California, slightly cooler than average of the northern Rockies, but then things do heat up going into the weekend across California and the interior west. By Sunday, Monday, things get quite toasty across really mainly the inland areas of California. So this heat wave is likely to be most intense for a brief period, Tuesday through Thursday or so next week in the northern Sacramento Valley. This is showing some pretty large anomalies on the order of 14 or so degrees centigrade. So that's well over 20 degrees Fahrenheit above average for the northern Sacramento Valley. in a Tuesday, Wednesday period. And then again in the northern Sierra foothills, expanding across all the North Valley and into the northern mountains. There's even some 16, 18 centigrade above average values. So again, take the centigrade difference and multiply by 1.8 to get the Fahrenheit anomalies. This is suggesting that Wednesday and Thursday could be very hot days across portions of Northern California, particularly in the northern mountains and in the Sierra Nevada and its foothills, but also to a slightly lesser extent in the Sacramento Valley, especially the north end of the valley. These are some big time numbers. And again, we know that there are, we've seen this in previous years, some issues with the ability of the models to get the modeled surface temperatures right, but this is suggesting at least that there's a high likelihood of temperatures well in excess of 100 degrees in the Central Valley on these days next week, maybe locally approaching 110 degrees in some places in the Central Valley. I think more notable may be the 90 to 100 degree temperatures, though, in the deserts of western Nevada. So Reno could get up into the upper 90s by this point next week, and that's really notable given that a 100 degree day in Reno is a notable heat event at any time of year, let alone in early June. So these are pretty darn hot temperatures, even though they don't seem that hot compared to, say, an ordinary hot day in Death Valley. Of course, everything is relative. It's all contextual. But this is only giving us part of the story. So I want to actually zoom out to the scale of North America. And we're once again resetting the clock. This is what things look like right now. And I'm going to go back to the height anomalies here. This is the way things are at the moment. But if I move forward in time again, what you'll see is actually Sunday into Monday, there's a significant storm that's going to move into the Pacific Northwest, a late season storm, a pretty strong atmospheric river. And if I indicate the precipitation that's likely to occur up there, this is going to be a pretty soaking rain event for the coastal BC and all the way into Oregon. There's even going to be some light rain down into the far north coast of California Sunday. This is immediately preceding what could be a pretty significant heat event, which is unusual in the sense that there will be a bunch of moisture on the ground immediately before it gets quite hot up in BC, Washington, and Oregon. Less likely in California, although again, up by Eureka, Arcata, there could be some meaningful precipitation right before things warm up. But the reason I'm raising this is kind of an interesting little feature, this atmospheric river, and it's actually something that I'm not quite getting the panel that I want here. I wonder if I go to, let's see, North Pacific, give you the big view. Yes, okay, so here's what we're going to see. This is, again, moving forward in time. You see, I'm going to scroll down so this appears better on the screen. You see this plume of anomalous moisture. This is that atmospheric river I mentioned moving into the Pacific Northwest. I'm toggling back and forth in time, Sunday into Monday, and maybe even into Tuesday. But look at what sort of happens. It's not going to rain in California, but there is going to be a deposit, if you will, of unusually moist air. So there will be some clouds around, and it might even feel a little bit muggy to start out this heat wave. So there's this deposition of moisture-rich air, and I'm going to go back in time now a little bit. Look at where this is coming from. There's a typhoon, or a tropical cyclone at least, south of Japan. This was back on Monday of this week. As you follow this feature, as it arcs northeastward, watch what happens as this recurving typhoon becomes a major storm near the Sea of Otansk, and then progresses eastward through the Bering Sea. The low pressure system sort of does a little handoff between the parent low that was the old tropical cyclone and allows this next one in the Gulf of Alaska to deepen. This path, this trajectory, it's a late season extension of the storm track into the Pacific Northwest. This does occasionally happen, and it is more than once. This has been the result of recurving late season typhoons. It tends to energize the jet stream. But look at what happens is this sort of slings some very moist air towards the western U.S., and it kind of lingers. This is now at the peak of the heat wave, and look at this. There's still some sort of moisture lingering in this region during the heat event, at least at upper levels of the atmosphere. It may not feel super dry near the surface. Once again, that recurving typhoon, if I go back in time, you can see, look how the jet stream is pretty weak and wobbly, but then look what happens once this typhoon recurs. It strengthens and has this brief extension all the way across the Pacific, unusual for June, making it all the way to the Pacific Northwest. This is when we get the atmospheric river event. And then there's a wave breaking event. So see how we go from this roughly west to east positioning of the jet, and then we start to see this anticyclone form and this anticyclonic wave breaking, with the Pacific flow falling well up into and then weakening as this ridge, sort of this big honkin' ridge, gets going. And then the jet stream pretty much falls back to its climatological situation. But watch what happens again with the height pattern. So we get this extended jet, so high heights over California, low heights over the Pacific Northwest. That's indicative of the strong jet. This is the atmosphere. And then the heat event develops, and we get this big blocking ridge. And it just kind of sits there. It doesn't really go away. So there's a couple of things going on here. One is that the recurving typhoon is partly responsible for this upcoming atmospheric river in the Pacific Northwest. It's responsible potentially for helping develop this anticyclonic wave break that sets up this big ridge downstream. But the other thing it's doing is it's injecting a lot of really advecting, I guess is the meteorological term, a bunch of very relatively warm, moist air, and more importantly, because there is the cloud formation and precipitation occurring, there is going to be a major latent heat release during this period. So essentially up in this region where there's a bunch of extra precipitable water, during this period right here, where these features make it to the coast, there's going to be a bunch of latent heating of the atmosphere in this region that's shortly thereafter going to become the heat wave region. That release of latent energy in the air that has a lot of water vapor in it, as that water vapor, and this is of course what latent heating means, as all of that water vapor that's in the atmosphere condenses into clouds, that process of condensation releases energy, and it essentially results in a conversion of that energy from latent energy stored in the vibrational energy of that water vapor, and converts it to sensible heating. Sensible, S-E-N-S-I-B-L-E, meaning that you can really feel it. So this is an actual increase in the temperature of the subsequent air mass. So you convert some of the energy that's stored in the high energy form of water vapor to the lower energy form of water droplets, which is what clouds are made of. That releases energy, or converts energy, I should say, from latent to sensible form. It causes an increase in temperature of the air mass. And as precipitation occurs, it means that you can continuously release more and more of that latent energy, converting it into sensible energy with each increment of precipitation. So the significant precipitation event up in the Pacific Northwest will be releasing or converting a significant amount of latent heat to sensible heat. And that's suspiciously right before a significant heat event evolves. So that is to say, this tropical cyclone, this typhoon from the West Pacific, is doing several interesting things. It's energizing the jet stream and allowing this atmospheric river to make it to the Pacific Northwest at a somewhat unusual time of year. It's also amplifying the jet stream and helping this ridged anticyclonic wave breaking pattern form in the first place. But then it's also going to allow for a significant of the sort of heat dome that's developing. And note, if I bring up this temperature pattern again, this is the period, as these are 5-day moving averages for surface temperature anomalies. The atmospheric river period, it's a little bit cool up there because of course it's cloudy and raining rather than sunny. But then look what happens immediately afterward is this large area of much warmer than average temperatures in Western North America immediately follows. And I actually think that a significant component of this may be the latent heat release and the subsequent fact that the atmosphere then it essentially descends in the subsiding air mass. In this region here, you get downward movement of air within high pressure systems, and especially mid-tropospheric ones that are persistent. That tends to result in a drying and heating adiabatically of that air mass. And then essentially what you get are even hotter temperatures than you would have gotten otherwise. So it is possible for latent heating, so having a bunch of precipitation and clouds immediately prior to or just upwind of a big ridge of high pressure, to actually cause the heat within that high pressure system to become even greater than it would have been had the air mass preceding it been dry. This is a mechanism that's been identified in the June 2021 heat wave as well,